Dear students, welcome to Tungala online classes. So in the last video, we were discussing what are biomolecules, what are the types of biomolecules, how animal as well as plant tissues are containing these biomolecules, right? What are the examples for biomacromolecules and biomicromolecules? All these are the things that we have already studied in the last video. In this video, we will start with the next topic, that is metabolites, right? What these metabolites are? The question arises. As you know, in both plant as well as animal cells, so many number of chemical reactions are taking place, and all those reactions together called as metabolic activities or metabolic reactions, right? And the products, many number of products are synthesized during those metabolic reactions, and those products are called as metabolites, right? As we know, so in plant as well as animal cells, so many number of chemical reactions are taking place, and all those set of chemical reactions together called as metabolic activities. What they are known as metabolic activities. These metabolic activities are taking place as a result of which many number of products have been produced as a result of these metabolic activities, both in plant as well as animal cells. And these products are known as metabolites. What these are known as? Metabolites. The products which are produced or synthesized as a result of many number of chemical reactions or the metabolic activities called as metabolites. Now you are very clear with this aspect there, right? So what kind of products are produced over here? The question arises. So as you know, in plants many number of products are produced as a result of the chemical reactions. Those are usually, so maybe nucleotides are produced over here. Glucose is commonly produced over here, right? And such kind of many number of products have been produced during fats are produced. Many carbohydrates, fats, proteins, all these are the things that are produced as a result of normal chemical reactions called as metabolic activities in both animal as well as plants, and those are called as metabolites. Okay, these metabolites what are produced as a result of metabolic reactions, they have been classified into two types. One is called as primary metabolites, and the second one is called as secondary metabolites. Primary metabolites, secondary metabolites are the two types of metabolites that we come across. What is the difference, major difference between these two metabolites is the question arises. See here, so one is primary metabolites. These are the metabolites which are synthesized as a result of normal metabolic activities or normal metabolic reactions, right? These are the products synthesized as a result of normal metabolic activities. they are called as primary metabolites. Primary metabolites. They are called as primary metabolites. Right? So example for these one are, so already you know some of the sugars like glucose is normally produced in plants, right? Glucose is produced. So many number of fats are produced, many number of proteins are produced, even some of the amino acids are produced over here. Some of the normal steroids are produced over here, and all such kinds of products which are produced as a result of the normal metabolic activities called as primary metabolites. These are one kind of metabolites, and second type of metabolites are secondary metabolites. Secondary metabolites. These are the kind of metabolites which are produced as a result of the metabolic reactions or the activities, but changed metabolic activities. So these are the metabolites which are produced as a result of changed metabolic activities. Changed metabolic activities, right? So such kind of metabolites are called as secondary metabolites. They are called as secondary metabolites, right? So example for these one. In plants, especially primary metabolites are usually formed in case of animal cells. In animal cells, these are quite natural, right? But in case of some plant cells, such kind of changed metabolic activities are happening continuously. So, and as a result of which many number of products have been produced, and such kind of products which are produced as a result of changed metabolic activities, they are said as secondary metabolites. Right? I hope it is very clear to you now. Right? Example for these one are many number of alkaloids. Catharanthus roseus, Vinca rosea are the type of plants which are normally growing around our houses, right? So they are bearing some kind of white as well as pink colored flowers, right? And those flowering plants produced one of the alkaloid, vincristine as well as vinblastine are the alkaloids which are produced over there. They are anti-cancerous in nature. See here. So this is one product which is produced as a result of the metabolic activity, but the metabolic activity is changed metabolic activity. So because of this reason only, the same kind of metabolic activities does not take place in all the plants, right? If the products which are produced as a result of the common metabolic activity, they are said to be as primary metabolites, right? But the same product, so which is not produced by normal metabolic activities over here, I mean alkaloids, they are different. Alkaloids are produced over here, right? And along with this one, some more chemical components like, right? So what kind of chemical components are produced over here are scents, spices, right? Rubber, many number of essential oils are produced over here as a result of this one. Rubber is produced over there. So these are usually not at all produced in all the plants. In a rubber plant only rubber is produced. It is produced as a result of a changed metabolic activity, right? So alkaloids are produced, rubber, some of the essential oils. See, in plants, many number of oils are produced, but in particular plants, oils are produced. Groundnut, right? Such kind of products which are produced as a result of changed metabolic activity are said to be as secondary metabolites. So alkaloids are produced, rubbers are produced, essential oils are produced, right? And many number of flavoring agents. Many number of flavoring agents are produced over here. Saints are produced. Many number of drugs are produced. Many number of drugs are produced. All these are said to be as secondary metabolites, right? So I hope you came to know what actually the metabolites are, what are the types of metabolites, as well as what is the difference between primary as well as secondary metabolites. In your NCERT book, so he has given some of the secondary metabolites there in one of the tables. So and those are very important, as you know, in a NEET examination these are quite common to ask, right? So that's why you have to focus on those such kind of tables across the NCERT book, right? So let us go through all those examples. Let us see, let us analyze all those one now. Yes, here are the list of secondary metabolites, right? What are the secondary metabolites they are given? Let us see now. Some of the pigments, some pigments are acting as secondary metabolites like carotenoids, anthocyanin are the type of pigments which are said to be as secondary metabolites. Anthocyanin, as we have studied, it is present in the cell sap, which is present inside the vacuole, large vacuoles, right? And the next one is some of the alkaloids like morphine, codeine. So these are a kind of alkaloids which are produced in some of the plants, right? So those plants, so they are producing the products which are formed as a result of different or another type of metabolic activity, right? Morphine as well as codeine. Codeine has, so it has one unique feature that cough syrup contains this codeine itself, right? So that kind of relieving capacity these alkaloids have. Next one, terpenoids. Some of the terpenoids are also the secondary metabolites. So like monoterpenes, diterpenes are the type of terpenoids which are produced as a result of some altered metabolic activities. Next one, essential oils. Lemongrass oil, eucalyptus oil. So these are the different types of oils which are acting as the secondary metabolites. And the next one, some of the toxins are also produced as a result of secondary metabolic activities, that is arabin, resin are the type of toxins which are produced over here. Lectins are produced as a secondary metabolites. So concanavaline, so is the type of lectin produced over here as a secondary metabolite. Some of the drugs like vinblastine as well as curcumin are the type of drugs which are acting as the secondary metabolites, which are formed as a result of the different type of metabolic activities, right? This is over. Next one is some of the polymeric substances. Some of the polymeric substances like rubber, gums, resins, cellulose, these are some of the polymeric substances which act as the secondary metabolites, right? So such kind of secondary metabolites, sometimes they act as antibiotics. They act as antibiotics, and even they give coloration. They provide coloration. So coloration is helpful for the plants to attract the insects towards themselves so that pollination occurs. So coloration that provides pollination, right? So this kind of antibiotics are also secondary metabolites, and coloring agents are also secondary metabolites, and even flavoring agents are also the secondary metabolites. Such kind of many number of activities have been done by these secondary metabolites also, right? So this is all about the metabolites and their respective types over here. Now we shall start with one of the carbohydrates, so as one of the biomolecules, right? So what are these carbohydrates? Let us go through. So these carbohydrates are simply called as sugars. What these carbohydrates are? These are the organic compounds which are made up of mainly carbon, hydrogen as well as oxygen, right? So these are organic substances or compounds which are made up of carbon, hydrogen as well as oxygen. So here the ratio of hydrogen and oxygen is 2:1 in these cases. It is always 2:1 in these cases. So the general formula of these carbohydrates is CnH2O n times, or it is also said as CnH H2OA. So this way also it is written. Say for example, so if you take this as general formula, if the number of, see here, n equal to number of carbon atoms, if n equal to 6, then what would be the product that we get over here is, so you just write here C, n means C6, H2O6 means C6, H2O6. This is nothing but glucose. Is one type of what? Carbohydrate. But in case of general formula, many exceptions that we come across over here. So what are the exceptions that we come across here? If we consider the general formula is the major aspects, alright? So deoxyribose is taken as an example over here. So what it shows is it is not suitable for this general formula. There are many exceptions that we come across. One is deoxyribose. It is a kind of sugar. It is a kind of pentose sugar. It is. What kind of sugar it is? Pentose sugar. 5 carbon atoms consisting of. So C5H10O4 is the molecular formula of deoxyribose. Here 1 ratio is not seen over here. So that's why even though it is a carbohydrate, this formula, this general formula is not suitable for this deoxyribose. Such kind of many exceptional cases that we come across over here. In case of formaldehyde, as well as in case of another product, one is formaldehyde and acetic acid. Acetic acid. So the hydrogen as well as carbon as well as oxygen. If you take this ratio over here, that moment, so we will not get so the suitable ratio between over here. So it is 1:2:1. Its ratio is 1:2:1. So say for example CHO. If you take like this, so then it is 1:2:1. It is hydrogen carbon as well as oxygen ratio comes like this. But actually the ratio doesn't match to this formula, right? So this is also one exception on this. So these are actually not the sugars, formaldehyde as well as acetic acid. So these are not sugars over here. These are not sugars, but so the formula, so it is somewhat so match to this one. For this reason, these carbohydrates are defined as definition of these carbohydrates. How to define these carbohydrates? Carbohydrates are nothing but they are the polyhydroxyaldehydes or ketones. They are said as these carbohydrates are defined as the polyhydroxyaldehydes or ketones. These contain aldehyde group at the terminal part of the compound, and these contain ketone group in the middle part of the compound, right? So these contain aldehyde group, means CHO group. It contains CHO. This aldehyde group. Keto group in the center like this. Keto group is also, it contains, right? And such kind of compounds which are said to be as defined as the polyhydroxyaldehydes or ketones. Why? Because at the terminal part they may contain aldehyde group, and in the middle part they may contain keto group. So that's why these are said to be as polyhydroxyaldehydes. Ketones they are said to be as. And these carbohydrates make the 80% of the dry weight of the plants. So these carbohydrates makes 80% of dry weight of plants. So this is more important, means maximum part of the plant body itself is made up of these carbohydrates, we can say. Alright, so that's why ultimately we came to know what are these carbohydrates. These are organic substances or the compounds which are made up of CHO. So mainly it is consisting of carbon, hydrogen as well as oxygen. Hydrogen as well as oxygen ratio is 2:1. So this is the general formula of these carbohydrates. And when you take the general formula, if you take the number of carbon atom 6, then we get here one of the sugars, that is glucose. And deoxyribose is exceptional to this general formula because its ratio is not 2:1. Hydrogen oxygen ratio is not 2:1 over here. And in case of formaldehyde as well as acetic acid, whenever we see the ratio over here between the CHO, that moment it is 1:2:1, even though these are not sugars. Even though these are not sugars over here. Then what these carbohydrates are? These carbohydrates are nothing but they are defined as polyhydroxy aldehydes as well as ketones. Why? Because they contain both aldehyde group as well as ketonic group. So in the terminal part as well as middle part respectively. So and these carbohydrates makes 80% of the total dry weight of the plant body. And these carbohydrates are classified into three major groups. So what are those three major groups? So they are monosaccharides, oligosaccharides, polysaccharides over here. So they are classified this way. What is monosaccharides, oligosaccharides as well as polysaccharides? So let us go through. Now the classification of these carbohydrates. See here. So as to understand the classification of these carbohydrates, there is a need of understanding reaction. And this reaction is called as hydrolysis. Hydrolysis reaction means what? So it is nothing but breakdown of a molecule, that is sugar molecule, by addition of water here. When you add the water, the moment of breakdown of the sugar molecule that takes place over here. See here, so how many monosaccharide units the sugar molecule is broken down into based on it. So they have been classified into different types of sugars, right? Different types of sugars. What are those types of sugars? Let us see here. One is monosaccharides. And the second one is oligosaccharides. And third one is polysaccharides. So see here, this is an exceptional case. If the breakdown of the sugar molecule takes place into how many monosaccharide units? So that's why monosaccharide units are mentioned over here. That's why this will be single. That's why it is an exceptional case. Means these sugars do not undergo any hydrolysis reaction. These do not undergo any hydrolysis reaction. They are monosaccharides over here. So, but oligosaccharides as well as polysaccharides. Here these are classified on the basis of this hydrolysis reactions. So hydrolysis is nothing but addition of water to the sugar molecule. So when sugar is added with the water, it is broken down into many monosaccharide units, and based on the number of monosaccharide units, they have been classified into oligosaccharides as well as polysaccharides. But monosaccharides do not undergo any hydrolysis reaction, right? So this is the fact what you should remember from classification. So first of all, we will go to the monosaccharides. Monosaccharides, as the name suggests, mono means single. Mono means single. Saccharon means sugar. These are commonly known as simple sugars. Simple sugars, these are commonly known as. And these simple sugars are made up of 3 to 7, means they are consisting of 3 to 7 carbon atoms. So in their structure they contain 3 to 7 number of carbon atoms over here, and such kind of monosaccharides do not undergo any hydrolysis, and the structure may have aldehyde group on the terminal part, and they may have the keto group at the middle part. Here is the terminal, is middle part, right? The structure of these monosaccharides may contain 3 to 7 number of carbon atoms over here. The structure ends with aldehyde group, or in the middle keto group may be present over here. Alright? So the most common monosaccharides are pentose sugars as well as hexose sugars. So what are these pentose sugars as well as hexose sugars? The question arises. So based on how many number of carbon atoms they contain, based on that they have been named with different names. Say for example, see here types of monosaccharides. Based on number of carbon atoms. Based on the number of carbon atoms here. If 3 carbon atoms containing sugar is there, then it is called as triose. If 4 carbon containing one is there, it is called as tetrose. If 5 carbon atoms are there, it is pentose. If 6 carbon atoms are there, it is hexose. If 7 carbon atoms are there, heptose. So like this, based on the number of carbon atoms what they are consisting of, based on that they have been named. If the carbohydrate contain aldehyde group, then they are called as aldoses. If the carbohydrate contain keto group, they are called as ketose sugars. These are called as aldose sugars. Like this, based on the type of group, right? So that contains, they have been named as aldose sugar as well as ketose sugar even, right? So now we can know, so these pentoses as well as hexoses are the most common type of monosaccharides over here. What are these pentose sugars? What are these hexose sugars? Some examples we can take and we will draw the structural formula of the same over here. What are the trioses? What are tetroses? What are heptoses? All these are the things that we study now itself. First one is triose. Triose. These are the simple sugars. Sugars contain 3 carbon atoms. So, say for example, general formula you take here CH2O. If n equal to 3, then C3H6 okay. Right? This is the formula of this triose. The best example for this one is glyceraldehyde. Glyceraldehyde is one best example, and another example for this one is dihydroxy acetone. Dihydroxy acetone. So these are the 2 best examples for triose. So which contain 3 carbon atoms over here, and these are the intermediate compounds formed during photosynthesis and respiration. These are the intermediate compounds formed during photosynthesis as well as respiration in plants, right? So these are triose. And the next one is tetrose. These are simple sugars with 4 carbon atoms. The general formula you may take over here. So if n equal to 4, then CH2O n times. So means C4H8O4 is the tetrose formula. Tetrose sugar formula. So the best example for these tetrose is, so one is erythrose and triose. One best example for this one is erythrose and triose are the best example for these tetrose, right? So this is one more. And the next we shall go to the pentose sugars. Very important one. Pentose sugars. These are the simple sugars. With 5 carbon atoms in their structure. They contain 5 carbon atoms in their structure. So for example, so one pentose sugar is ribose. Ribose is one pentose sugar, and deoxy. Ribose is another pentose sugar, and ribulose is another pentose sugar. All these are the pentose sugars that we come across over here. So in that, ribose sugar is one type of pentose sugar whose structure is How its structure is, let us see here. It is a pentose sugar. This is carbon number 1, 2, 3, this is 4, and here we come across fifth carbon atom, CH2OH group. OH group that we come across over here, and here also OH group, and in this, then OH group is present in the first, third, as well as carbon atom. In case of reverse, then it is HH, and this is OH, and here also OH. This is the ribose, one pentose sugar. In the same way, deoxyribose, whenever you consider the same type of sugar that we come across over here, it is also a pentose sugar. Carbon atom number 1, 2, 3, 4. Once again it is fifth carbon atom, CH2, OH is there, one oxygen is there. Here also it is OH, H. But here in this case, in case of deoxyribose, so one oxygen atom is absent over here. So this is OH group. Here also OH group, first, second, as well as third group. So in fourth group it is absent, in fifth group it is present. So like this, so there, this is the deoxyribose sugar. This is ribose sugar. Ribose sugar, deoxyribose sugar is seen over here as structurally. These are very important, and ribose sugar is present in RNA. So ribose sugar is present in RNA, deoxyribose sugar is present in DNA. Deoxyribonucleic acid, it is called as ribonucleic acid, it is called as, right? And this RNA as well as DNA are acting as the genetical materials. What they are acting as? These are acting as genetical materials. These are genetical aspects. These are genetical materials they are present in, right? So these are the genetical material which contain mainly the pentose sugar like ribose as well as deoxyribose sugars it contains mainly. Okay, in the same way ribose is one of the acceptor of carbon. Action during photosynthesis. See here, during the photosynthesis what happens? Inhalation of carbon is being done by the leaves of the plants. When carbon is intaken, that moment that carbon is fixed, so as to synthesize the sugar over here, that is glucose sugar over here, right? So that's why carbon acceptor is ribose, is one of the pentose sugar here, right? So these are nothing but different types of pentose sugars that we come across. They play very important role because they are present mainly in genetical materials, right? So which are inherited to the next generation. That's why, so these play very important role. The most common, so sugars are simple sugars are pentose sugar itself. And the next one is hexose sugar. Glucose, galactose as well as fructose are the types of what? These hexose sugars. What are their importance? So how they are? All these things let us see now itself. But one more thing we must remember here, in case of pentose sugar, arabinose is also another type of pentose sugar. Gylulose is also another type of pentose sugar which make the secondary wall of cell wall in case of plants. Next one is hexose sugar. What is this hexose sugar? Hexo means 6. It is 6 carbon containing sugar, simple sugar is, right? So general formula you take CH2ON times. If N equal to 6, then C6H12O6. So this is nothing but one type of hexose sugar. This is nothing but glucose. Glucose is one best example. Another one is fructose is another one, and galactose is another one. So glucose, fructose, galactose are the kind of hexose sugars over here. So they are the kind of hexose sugars over here. They also play very important role over here. How? So say for example, first one I shall take, that is glucose, C6H12O6. So is glucose. So this is one of the sugars, hexose sugars, which contain 6 carbon atom within it, and this glucose is called as blood sugar, right? It is called as blood sugar or respiratory substrate. It is acting as. Why it is called as blood sugar? Is because in blood, sugar will be in form of glucose or base. So that's why it is called as blood sugar. So blood sugar level you may have of, right? So why it is respiratory substrate? Why? Because the breakdown of this glucose takes place during. So the breakdown of glucose that takes place during respiration. The breakdown of glucose takes place during respiration. Means inside the cell, respiration is taking place. It is called as cellular respiration. During cellular respiration, energy is released. Energy is released on oxidation of this glucose. On oxidizing this glucose, energy is released in the cell, especially in the powerhouses of the cell called as what? Mitochondria. There, hence this is called as the respiratory substrate. Is called as. So what is called as the respiratory substrate? So this glucose is called as a respiratory. So substrate it is called as. And this glucose is also known as. So what? Blood sugar. Blood sugar is also known as well as this is also known as grape sugar. In the grapes especially it is present. And what is the sweet index of this one? So it is about 70. The sweet index of this one is 70. And the next one is fructose. What is this fructose? So this is commonly known as fruit sugar. It is commonly known as fruit sugar since it is containing means it mainly present in fruits. Hence it is called as fructose is called as fruit sugar. And this fruit sugar is sweetest one. Sweetest sugar. So that sweet index of this one is 170. It is about 170. And this fructose is called as ligulose. Why? Because it is leo-rotatory in nature. What do you mean by leo-rotatory in nature? When a ray of light is passed through this fructose, there the ray of light so that reflects, so on the left side it can turn on its left side, so that's why these are called as leo-rotatory. So hence this one is called as ligulose. If the ray of light that bends upon, so that bend towards the right side, dextro-rotatory they are called as. But here fructose is called as the leo-rotatory one, right? Leo-rotatory. So sugar this fructose is. So which is commonly known as fruit sugar, right? So this is one more aspect to be remember. So sweet index itself is 170, hence it is very sweetest sugar of all the sugars, right? And this fructose, so this fructose is very important to why, because it is sweetest one. And galactose is another hexosugar which is not available freely. Not available means it is always with another what? Sugar itself. So in case of lactose, this galactose is present in lactose. Lactose contains galactose itself. And this galactose is forming the cell wall materials like, so it is in pectin. So some of the polysugars like pectin is present in a pectin, mannose. It is present in mannose, pectin. Such kind of polysaccharides can make, right? And this fructose can also make some of the polysaccharides over here. This is all about the three kinds of hexosugars. One is glucose, fructose, galactose. So galactose makes many of the raw materials like pectin, mannose. Even it is present in mucilage, gums, etc. Right here, mucilage. Gums, etc. Okay, and this glucose that can make the polysugars like starch, glycogen, etc. Right? So they play a very important role for forming all these polysugars even. Right? So these are all what? Monosugars. And one more is there, heptose. Right? So hepta means 7. So 7 carbon atom containing. So that is sugar. So let us see it now. Heptosis. So these are 7 carbon containing sugars. 7 carbon containing sugars, they are heptoses. So and such kind of heptoses, the best example for these heptoses are, so what? Glucoheptulose as well as pseudoheptulose. What are those ones? pseudo haptulose are the best example for these haptuloses, right? So these are 7 carbon containing sugars. So you may take the general formula here. General formula here. You may write C7H12O7. Right? So these are the molecular formula of these haptoses. So by this we completed all the types of monosaccharides, and these monosaccharides have their own what? So characteristic features. What kind of chemical properties as well as physical properties are the characteristic features, what they are. So all those things let us study in the next video. Thank you.